Hello, one and all. Welcome to 27 Virtual's webinar series, starting with Securing vSphere. My name is Jacob Bagwell, Senior Architect with 27 Virtual, and I'll be your host for today's session. So we'll give everyone a couple minutes to be able to join in with us, and then we'll be able to get started. Let's go ahead and bring up our slide. So today's session, Securing vSphere, will be centered around getting started with vSphere security. And breaking up vSphere is very interesting, right? We have so many aspects that come into vCenter from our vCenter server, we have our ESXi hosts, we have the physical hardware on those hosts, as well as the virtual networking that connects them all together. So, why should you listen to us? Well, 27 Virtual, our services, complexity simplified. So, 27 Virtual is a trusted VMware partner focused on advanced services within the VMware portfolio. What sets 27 Virtual apart from other partners is that we empower your organization with knowledge, confidence, and ownership of a solution. Our consultants have spent years leading high profile customer engagements, but have also led workshops and classes, spoken at conferences, and engaged with the VMware community. For example, the NSX Ninja program is one that 27 Virtual has led since its very inception. So, for today's agenda, as we touched on earlier, we'll be going through our vSphere security assessment and design. So when 27 Virtual first comes in, for example, in one of our security projects, we always go through an assessment and a design phase. By doing so, we're able to understand your environment and what makes the most sense for security, because everybody's environment should be fine-tuned to their specific needs and concerns as a business unit. Next, we'll have physical hardware hardening, diving into how do we make ESXi from the ground up secure. Once we get past our physical hardware hardening, we'll have ESXi host configuration for security. Then we'll be looking into securing the vCenter configuration itself, the brain that controls everything underneath it, as well as our VMware hardware security, and then finishing off with VMware security. We'll also have a dedicated section for questions at the end. But feel free in the comments if you have any specific questions about the content that we are going over. Absolutely feel free to chime in and we will try to get your question answered. So, starting with vSphere security assessment and design. So this is when we're going to determine each application's service level objectives for security and apply the appropriate tools and technologies to meet those requirements. Not every customer is going to want every single security option enabled that vSphere has for it. It'll either be not efficient and very slow, or just not feasible depending on the exact hardware that we have. So we'll go through each step of vSphere, right? Again, your vCenter, your VMs, your ESXi, the physical hardware. For vCenter, we're going to look at things like identity provider for single sign-on, certificate management, making sure that everything can, every VM or appliance or host and client can talk securely over known certificates. For the VMs, looking at turning on UEFI secure boot, encrypting those VMs, encrypting their core dumps, and then even encrypting them in motion with vSphere vMotion. We'll also bring that UEFI secure boot into ESXi itself. We can look at fine-tuning access into those ESXi servers with host user access, lockdown mode. And then for the connectivity between all of them, we can look at virtual switch port groups and port group security policies. We'll even be able to tune in a little bit with adding something like VMware NSX for securing those distributed port groups even further. And finally, the iSCSI target authentication, NFS target authentication, making sure that the data stores, the solutions for storage that ESXi and the rest of vSphere will be utilizing is also secured. So a lot of the times when we're doing our assessment and design, we're going to be following what VMware recommends for their customers, right? It has VMware has created and distributed, so it should be available for everybody. The vSphere Security Configuration Guide. So this is a set of baselines and security best practices for your company to see what works best for you and to enable them, including descriptions, any potential discussions that need to happen around it, and of course anything that needs to change to support, even from a process standpoint, when you activate these new security features. So it's not intended for you to just get this document and then go in and turn on all of your security features. But it allows you to look at the individual security features for those that are most relevant for your business's needs. So, starting again from the ground up, the physical security hardening, right? The hardware that we have our ESXi hosts installed onto. There are four main features and topics that we can take a look at when it comes to hardening those physical hosts, right? We have our secure boot, we have TPM, we can look into the firmware, and even how ESXi uses its processor across VMs for processor security. So, starting at the top, we have UEFI Secure Boot. This will be vendor specific depending on where you got your ESXi hosts from and who is the manufacturer. But ultimately, what UEFI Secure Boot does is it ensures drivers, applications, and VID packages are signed. And this is only available in vSphere 6.5 or higher. Even 6.5 is no longer supported. So most of you should be on at least 6.7 to 7.0, where again, this feature set is available. And in fact, you even get some additional features for security with UEFI. So when we enable secure boot, the boot sequence goes as follows, right? The ESXi bootloader contains a VMware public key. So the bootloader is going to use this key to verify the signature of the kernel and a small subset of the system that includes a secure boot VIB verifier. The idea here is we need to set up a root of trust, which if you're not familiar in security terms, is your baseline. This thing is trusted, and if it trusts something, that means the thing that it's trusting is trusted, which starts with the ESXi bootloader and even the firmware on that specific host. So after the bootloader has used the key to verify the signature of the kernel, it's then going to set up a VIB verifier, which will verify every VIB package that is installed on this system. And at this point, the entire system can boot with the root of trust in certificates within that UEFI firmware, right? The idea is we go step by step to make sure the UEFI firmware with the public key and trusts the VMware public key, which then allows the VMware bootloader to go into the kernel, and then the secure boot VIB verifier to verify all of the drivers and modules on your ESXi hosts. With that said, we now know that we can run ESXi hosts in a secure manner because we have verified every step of the way in the act of booting up these specific hosts. Now, if you are interested in this for your environment, absolutely leverage your vendor-specific documentation to correctly enable secure boot at the firmware level. VMware has even put out additional explanations. So if you want more detailed guidance on this process, more than we can delve into with our 1-hour meeting today, we have some YouTube videos available from VMware and even an example utilizing Dell hosts. Now, you may be curious, in this process, if it determines something is insecure, for example, when the VIB verifier is taking a look at all the drivers and modules and VIBs that are a part of this ESXi install, what happens if they are not signed? VMware hasn't certified them. In that case, you get, unfortunately, a purple screen of death, but it will at least tell you what's happening with those unsigned VIBs. So, if you are looking to set up UEFI boot, an important thing is look at your vendor documentation, but then look at the VIB list on the ESXi host. If every VIB there is not verified, which you can find out via the CLI on that ESXi host, um, you will unfortunately end up in a bad place if you don't check that all of those VIBs are signed. And of course, then you can determine the necessity of those VIBs, which may or may not be signed, and then remove or look at an alternative VIB depending on its function. Now, so the next thing after UEFI secure boot, we have our TPM. This ties into UEFI to a certain extent and was introduced with vSphere 6.7. So TPM helps by establishing a hardware root of trust, right? With UEFI secure boot, the main thing that we're doing is securing the kernels and all of the software installed onto this host, right? But with TPM modules, we're actually able to establish that nobody has manually adjusted uh, the host hardware itself, right? So secure boot is going to validate the bootloader and VM kernel. Once that's done, various measurements are going to be written to the TPM, right? That the module installed on your host, a physical object that's allowed to validate the hardware of that ESXi host. vCenter is then going to validate these measurements against the host event log and VIB metadata and marks the host as attested or not. Then the secure boot verifier will continue and validate all remaining VIBs. So this brings that root of trust even deeper than originally with UEFI secure boot, because now it's no longer just at the kernel, it's at the hardware running the kernel, the bootloader, and all of your ESXi specific VIBs. And again, if you want a deeper explanation, we have a YouTube page there, which will be available after the end of this session. So we've done the hardware and we've done the boot up process to establish that root of trust. So next we move into the actual firmware itself. This is going to be a admin step in the process of securing vSphere, which is making sure that the firmware for all of the different hardware you have in your ESXi hosts is kept up to date, right? So firmware is microcode. It provides whatever necessary instructions are needed for that hardware to perform the tasks that it needs to properly and easily. So we want to make sure that this is also secured so nobody is hijacking hardware to make sure it's doing something different. So keeping the firmware for your physical NICs, your motherboard, any other items that could play into your host. We want to make sure that we keep those updated. Hardware firmware is not immune to serious issues affecting confidentiality, integrity, or availability. And vulnerable system management controllers and management engines can provide places for attackers to establish persistence. So this one means that even if you blow away that ESXi host when you notice something malicious is happening on it, because it's in the firmware of the hardware, just blowing away ESXi is not going to be enough. You would have to, ideally update that firmware to take out those attack vectors, or unfortunately, just taking the host out entirely. So a key note here, if you are a vSAN customer, please ensure that storage device and controller firmware versions are certified. What that means is you're going to be able to certify them from a security perspective, but also that vSAN is going to work with them. The last thing we want to do is have something very secure, but all of a sudden your shared storage between hosts doesn't work, right? Another nightmare scenario. So next we move into processor security. So when you install ESXi by default, it's going to utilize the default scheduler. And so basically this is setting up ESXi host on how it wants to assign actual CPU cores to VMs, and how do we want to make sure that the VMs and the processes on those VMs that are utilizing these cores are secure and have a good have a good performance, right? We don't want VMs waiting for a specific core because they need that specific core just for that virtual machine. Part of the benefit of virtualization is taking out specific hardware being utilized for virtual machines, right? So by utilizing the processor security and changing what we're looking at, we can fine tune that line between security and performance. So starting with the default, the ESXi host is the security boundary. There's no inherent security awareness. It provides the best performance because any VM, any process is going to be able to get any core uh, and have access to the CPUs. So to combat that, the first version of Side Channel Awareness or SCAV1 scheduler implements per process protections that assist with L1, TF, and MDS. It's the most secure scheduler. And you'll notice in the diagram here, right, we have this border saying where's the security boundary. So we're saying this ESXi host, it is not really securing the processes and the VMs from running from each other on those physical CPUs. With SCAV1, we're actually able to secure individual processes on the host CPU. So this prevents leaking secrets from leaking between processes within VMs, and individual processes are now your security boundary. But you do take a performance hit. And in fact, hyperthreading is not used when we're scheduling vCPUs with this scheduler type. So to combat some of the negatives of SCAV1, VMware implemented SCAV2 scheduler. So this implements per VM protections, right? It provides a balanced security and performance option where we're able to prevent secrets from leaking between VMs. And the virtual machine is now the security boundary, and we can allow hyperthreading. So this is a good middle ground between secure, all the processes on your VM will be put onto the same kind of cores and uh, the same threads, but we're not separating it per process. We're separating it per VM, so we can still set up hyperthreading that way. So, what is the process of implementing this? Because this process of setting up a processor security scheduler will be a little bit more complex than making sure your hardware and firmware versions are up to date, right? That's fairly easy, keeping up to date with the vendor for that particular chip or card, and just grabbing those updates. But with processor security, you need a process in place for actually setting up these different side channel awareness modules. We need to make sure that vCenter server and we need to make sure that ESXi are both updated and secure that way. There are always going to be security leaks when it comes to certain vSphere updates. So keeping an eye on any known attackers and known weaknesses or exploits is very important, and making sure you patch those exploits out. So we usually want to do that first in our update phase. However, you don't have to do that first. You could do it in conjunction with the planning phase, which is analyzing the environment for possible problem areas. VMware does have a tool available to assist in this process, uh, but ultimately it boils down to a couple of decisions. Do we currently have capacity issues? If not, we can just go straight to enabling the ESXi side channel aware scheduler. If we do have capacity issues, then we now need to ask ourselves, are all VMs and their hosts equally trusted? If not, we want to acquire additional capacity or rebalance existing VM workloads and then enable the side channel aware scheduler. This is really good for riskier environments within your vSphere environment, such as setting up a DMZ. Maybe that we would want to have a more secure processor security enabled there. For that, we would have the concurrent context attack vector mitigated, otherwise known as CVE 2018-3646 will be fully mitigated. And again, that the migration tool that VMware has, the HT aware mitigation tool, will actually be able to enable the scheduler for you at scale. So you don't have to do it one by one. But if we don't, if we do trust all VMs and their hosts equally, we accept risk of a concurrent context attack vector by not enabling, SCA v1 or v2. So if that's the way route we want to go, we need to perform a risk assessment of the environment. We need to determine what amount of risk is acceptable and then accept that risk to not enable those schedulers. So this is not a decision, VMware or us as consultants can really make for you. We can just give you all the information about it, and you guys can make an informed decision. But again, it's generally just not going to be recommended. At least having SCA v2 is recommended for most environments. Okay. So we have our hardware settled. We have root of trust built up. Now we can look at actually hardening the ESXi hosts themselves from ESXi. And we'll do that by looking at 5 different topics, right? We're going to look at the ESXi firewall. We're going to look at lockdown mode, password policy, VIBs and versioning, and then setting up logging in a secure manner. Now, I know ESXi firewall has a bad rep. Most customers will either just turn this off or not configure it to be as useful as it could potentially be. So even though it adds complexity, they are a necessary component in securing the environment. So these are common rules that we see in our engagements with the ESXi firewall between clients and vCenter, right? So between the users that are going to be accessing the vCenter web client, you want some sort of firewall rules there to make sure that not just anybody can reach vCenter, maybe a certain subset or subnet, or depending on what your firewall of choice is, if it's outside of ESXi, setting up something like NSX or a physical firewall. Then we want to set up rules between the clients and the individual ESXi hosts. This is when you're logging in directly into the web client of an ESXi host. For example, if there's a vCenter outage and you need to access the host vCenter is on, that's what this communication path is referring to. Finally, or between vCenter and ESXi hosts, obviously for vCenter to manage ESXi hosts, it has to be able to communicate with them. So we're able to firewall that down as well to make sure only the appropriate paths are available. So if somebody manages to get into vCenter, they have, or the vCenter like VM, for example, they have a little bit less capability of accessing those ESXi hosts and vice versa. Then between the individual ESXi hosts in your network, making sure that if somebody gets into the CLI of one ESXi host, they don't have carte blanche access to all of your other ESXi hosts. And then between your ESXi hosts and network storage, such as iSCSI. So consider using one or more of these firewall rules based on your internal security policies. Again, these don't all have to be implemented at the same time. They may not all work for your organization. So by default, ESXi firewall is enabled. So if you go into the individual hosts and you click on the configure tab within firewall under the system folder, you're going to see our firewall here. And it's going to show you all of the different connections incoming and outgoing, as well as when do you want to start and stop utilizing these firewall rules. So we have 3 options. We can start and stop with the host, which means as the host turns on, these firewall rules and the firewall in general will turn on or turn off with the ESXi host. Start and stop manually means somebody needs to come in here and click start for the particular service to work. It's good for, example like SSH, if we only want it on at a specific time, and we only want it available from specific clients, right? So only your admin PCs have access to SSH, to vCenter or ESXi hosts. And then we can start and stop with port usage, which will get a little bit more complex, and we can see that in our next slide here. So the security profile is what can determine some of the specifics about getting access through the ESXi firewall for specific services. Going back to that example I gave earlier with SSH, we can set it up with a security profile that says, allowing 22 incoming, right? So allowing ESXi to be the SSH server, um, we can turn that on only with specific IP lists. So we can see the 192.168.0.0/24. All of that network, if you have an IP address from that network, you'd be able to get through the firewall on this SSH. Right. All right. So moving into our lockdown mode. So this is a great feature for increasing the security of ESXi hosts, especially when we're looking at something like physical access to those ESXi hosts, right? If you have a monitor plugged in the ESXi host, you can get into the shell of ESXi, and you just need to know your root password or another password that may be available to get into the host itself to start making changes at the CLI level. But lockdown mode helps us to restrict that access. So we direct access to the ESXi host is direct access will be either restricted or fully denied. So that means all operations you would normally manage on an individual host must be performed by vCenter by default. There are two available modes here. We have normal and we have strict. So lockdown mode is normally deactivated, right? We're not going to just turn that on for every ESXi host that gets ESXi installed onto it. So you can enable lockdown mode via the vSphere client, either when the ESXi host is added to the inventory or later by editing the host security profile. And there we can see in that bottom picture some of the differences between normal and strict lockdown modes. So diving into them, with normal, we have the host is accessible only through the local console or vCenter server. So access to the web client for ESXi directly is not allowed there. And then strict takes away that first option, right? The local console itself will no longer have access to that. So all direct console UI service is stopped. And in fact, the actual service itself is stopped. So um, additional host hardening best practices, right? We have so many of these features. What should be turned on and why would you particularly turn on? So for this, we have some best practices available. Here are some of those guidelines. So the vSphere client will be utilized to connect to vCenter to centrally administer all ESXi hosts, right? That comes with normal usage of vSphere accessing your vCenter to centrally administer all your ESXi hosts, both for convenience. You can do all of multiple configurations on ESXi hosts all at the same time, but also from a security standpoint, it is preferable to go through vCenter. So the only time we want to revert to allow VMware host client, so direct access through the web console, is when central administration is unavailable. Going back to that example I gave earlier, if your vCenter server goes down, say its network got turned, somebody edited the VM itself and put it onto an incorrect network, and now your vCenter server has no network access. The only way to get to it is on the ESXi host that vCenter VM is currently located. We also want to avoid local user accounts and instead configure ESXi to use a directory service to manage users, meaning we don't allow people to just log in as root to do everything with ESXi. Instead, we give them a domain account. So that way we have a better way of tracking who is going in and doing what. And I find most of my customers already do this, but it never hurts to mention you want to keep the SSH and the vSphere ESXi shell services deactivated. And when you're actively troubleshooting, turn them on. And if you are using SSH, run that process under a sandbox domain. That way, the shell has reduced privileges and access to a limited subset of commands. And again, it's easier to track rather than everybody just logging in as root. And then Finally, for increased ESXi host security, consider activating normal or strict lockdown mode, although you do need some way of being able to access ESXi, at least where the vCenter is. So maybe keeping lockdown mode off of your management cluster if you have the capacity to separate your management workloads and your production workloads. So to help with that, we need to consider our access points. So most users that are going to interact with vSphere as a whole are going to be utilizing the vSphere client, right? Uh, Utilizing web browser HTTPS, going to the FQDN for our vCenter server, and then we're only allowing trusted users in. So it includes user root and service accounts when we're talking about ESXi hosts in detail. So on the left-hand side, we can see we have a user root or trusted ESXi user, which we want to allow, uh, generally speaking, to a number of different clients, right? The VMware host client logging in directly to an ESXi host. We want SSH access or VMware Power CLI for advanced scripting and management. And then, potentially in some troubleshooting use cases, the DCUI accessing the ESXi shell. But for non-trusted ESXi users, they're going to have to go through vCenter using Active Directory, OpenLDAP, or an SSO domain, going through the vCenter client, which is accessing our vCenter server appliance, which then manages our ESXi hosts, right? Keeping a number of layers between the untrusted users or just regular vCenter users from being able to access the ESXi hosts themselves. And of course, with many services that are running in organizations, we're going to need some sort of backup for our ESXi host. So if you have an image specific backup that's going in and accessing the ESXi host directly, a service account for that purpose would be excellent. So it can access the ESXi host directly without utilizing any other account or having to go through vCenter, depending on your backup solution. So we know our access points, but how do we want to restrict some of those access points? So we, as a guideline, want to restrict user access to ESXi. You may want to look at shortening the amount of time between required ESXi password changes, deactivate the vSphere client virtual machine console for specific VMs, and look at replacing the vCenter certificate with a trusted CA signed certificate. And of course, with all the different products within vSphere, there are a number of different password requirements. Um, so when you're utilizing vSphere or anything else within the VCF umbrella, you can see the password recommendations that we have on the right. So minimum length of 12 characters, maximum length of 20 characters. At least one lowercase letter, one uppercase letter, a number, and one of the following special characters, which you can see there. And it must not include a dictionary word, a palindrome, more than 4 monotonic character sequences, and 3 of the same consecutive characters. If you follow these recommendations, you'll have passwords that will work for any product within the VCF umbrella, including all of vSphere. So we've hardened our ESXi hosts. We've restricted the passwords. We've restricted access to only what we specifically want for specific clients and trusted users. But now we still had, vCenter users accessing vCenter. So how do we make sure that vCenter itself is secure and not giving access to users or malicious attackers? Well, again, we're going to look at 5 specific topics: vCenter network restrictions, distributed switch settings to secure the networking between virtual machines, authentication and access into vCenter, how do we want to back up and recover, and then securing logging for vCenter. So our vCenter is going to serve as a central administration point for ESXi hosts, ideally when your ESXi hosts are locked down. And it's also how you will administer virtual machines that are connected on a given virtual network. So it's going to direct the actions of VMs and hosts. vCenter Server itself is a Linux-based appliance. I believe it's still running Photon OS, which is a custom brand of Linux that VMware has developed for security purposes. And it has a password policy that auto expires every 30 days, but you can change and set that as required by your organization. So let's take a look at the network and access restrictions. So the vCenter server is supported by the vSphere client, the vCenter server database, and the managed hosts underneath it. So to protect against a potential compromise of your vSphere client, examine all installed plugins periodically and make sure that each plugin comes from a trusted source. So we can see in the diagram, we have our vSphere client over on the right. We have our host in the middle. So an ESXi host that's hosting our vCenter server appliance instances. And in that vCenter server appliance, which is above that host, we can see there is a Postgres SQL database that vCenter server is utilizing. And again, that Photon OS that's running the rest of the services for our vCenter server appliance. Now, with the vSphere client communicating directly with vCenter server, um, we need to think about how is it going to communicate directly with an ESXi host, or how we would connect with an ESXi host. So using that, we would do, again, our VMware host client, again, port 443 directly to the host. And you can see a little snapshot there in our image. But again, this is unavailable in lockdown mode. So again, depending on if you want to be able to manage your uh, ESXi host directly in the case of an outage of vCenter, maybe look at a management cluster and not activating lockdown mode on those specific ESXi hosts. Generally speaking, we want to place vCenter on any network other than the management network and restrict access. And then vCenter server really only requires access to a management network only. So where your ESXi management VM kernels are located, that's really what vCenter needs to access directly. So avoid putting vCenter server system on other networks, such as a production network or a storage network. And in fact, you can actually put on a network that doesn't have any internet access at all. Depending on the solutions you're utilizing within vCenter, it may not need direct access, or you may be able to use a proxy to give it access to specific websites in the case of using like Skyline, for example, for automatic updates to VMware support. vCenter Server does not need access to the network where vMotion operates. Even though it drives vMotion, it itself doesn't need access to that vMotion network. So we've been talking about the networks. Let's talk about our vCenter distributed switches. So VDSs have been around for quite a while. It's a virtual switch that we can configure for an entire data center. And in fact, depending on the version of vCenter and ESXi, so vSphere as a whole, you can get up to 2,000 hosts can be attached to the same distributed switch. So all 2,000 hosts can be attached to the same VDS and have access to the same networks that are created within that VDS. Obviously, if you're at the point where you're attaching, a four-figure number to a VDS, you very much want to go and take a look at the configuration maximums for your specific version that you're running of vSphere in your organization's environment. Utilizing this distributed switch, we can ensure that the configuration is consistent across all attached hosts. If you spend any time in the vSphere web client managing VDSs, especially during any sort of network migration, you might have seen vSphere will actually alert you if a configuration is different from a VDS and will allow you to remediate that automatically. But there is a licensing requirement. Hosts must either have an Enterprise Plus license or belong to a vSAN cluster, meaning you don't necessarily need Enterprise Plus if you have a vSAN license cluster. Now, before VDSs, we had a standard switch set up that we could utilize with early vSphere and ESXi. So this is just a virtual switch that is configured on a single host utilizing specific NICs. So if we wanted to utilize standard switches, that would mean we'd have to go to every single host in our environment to configure that. It's not centrally located. vCenter is not really managing it. It's specific to an ESXi host. And in fact, you can manage a standard switch by logging directly into that ESXi host client. Now, I've seen some customers not migrate to the VDS, thinking that, oh, we're already on the standard switch. We don't need any of the additional features. We can just leave things on the standard switch. But there are a number of security features only available on the distributed switch. So you can see here we have a chart, and on every single one of these security or distributed switch settings, some of which are networking, some of which are security based, the standard switch does not have access to them, while the distributed switch has access to all of them. So inbound traffic shaping, VM network port block, private VLANs, for example, with a DMZ, load-based teaming to make sure that we can change how packets travel across our physical NICs and how we want to team them, if we want active standby or load balancing, and whether that's regular load balancing or load balance based on a MAC address. Data center level management, meaning if you have more than 5 or so hosts, you can manage them centrally, easily, and all at once. A fun one is vSphere vMotion migration of virtual networking state, meaning a vMotion is going to be a little bit more disruptive when you're migrating on a standard switch rather than a distributed switch. We can set up port policy, per port policy settings, port state monitoring of network statistics, so we have a better idea of just how much traffic is actually going through these NICs. We can set up NetFlow, port mirroring for troubleshooting, access to NSXT port groups, which again is very useful for security purposes. For more on that, make sure to tune in to our next webinar on NSX. And then finally, the link layer discovery protocol. So we can actually see what information is actually trunked to these NICs from our top of rack switch. Of course, providing that the switch and version of your NICs support LLDP. Now, looking at the security settings in detail, we have 3 main options, right? Most people are going to be familiar with this if you're familiar with setting up a VDS in a vSphere environment, but promiscuous mode, MAC address changes, and forged transmits. Generally speaking, what we like to do, if these are required for an application, we want to set up a different distributed port group and apply these settings to that duplicate distributed port group, and then move that one application, whether it's a VM or a number of VMs, onto that distributed port group so that we don't take away some security settings for the rest of the VMs that are on that network, because we're separating it by distributed port group on that BDS. So looking into detail at those security settings, promiscuous mode is going to be how do we want VMs to receive frames that are addressed to that virtual machine. So by default, all of these are going to be set to reject. So with promiscuous mode, by default, VM network adapter receives only frames that are addressed to that specific virtual machine. But with promiscuous mode accept, the virtual switch forwards all frames to the virtual machine in compliance with the active VLAN policy for the port to which the VM network adapter is connected. Basically, what this means is any VM on the network can receive any of the packets that are going onto that network. So activating this is bad from a security perspective, but also from a strictly performance perspective. If your VM is now having to take a look at all packets that are coming into that VLAN segment, or that VLAN distributed port group, it's not going to have a good time. It's going to have to do a number of rejection of packets. MAC address changes. This makes sure that the VM is actually communicating with the MAC address that ESXi expects. So this is held in a VMX configuration file. And what this means is a VM can't change its MAC address and then continue to utilize the existing virtual NIC on that distributed port group. It would actually just get rejected. But if we have that turned on, then if the guest OS on a VM changes that effective MAC address of the virtual machine, the switch will actually allow frames to a new address to pass. Useful for something potentially like a load balancer, a virtual load balancer, for example. And then finally, forged transmits. By default, the switch is going to drop any outbound frame from a virtual machine adapter with a source MAC address that is different from the one in the .vmx configuration file. And if we have this turned off, to accept. The switch does not perform filtering and permits all outbound frames. So, looking at user access in vCenter, obviously we have a number of users that would need to access vCenter, but not all of them need access to the same things or the same amount of control in vCenter. So, we want to make sure that we are assigning the correct privileges to those users. So, role-based access control is well known throughout the industry. So using the access control system within vCenter, we can define user privileges to access objects in the inventory. So a privilege is an action that can be performed, such as power on VM, power off VM. The object is the target of the action, in this case, a virtual machine. And the user or group is an indication of who can perform said action. And we can bundle up all the different privileges that we want to be available to a user or a group um, in what we call a role. And then finally, permission is gives one user or group a role. So a permission is the assignment from a role to that specific user or a user group. So really quickly about roles, there are a number of predefined roles in vCenter. So privileges are going to be grouped again into roles. So by putting a user into one of these roles, they have access to all of the privileges that you'll see on the right side of the screen whenever you click on a specific role. So this is good when you have, for example, NSX administrators. They need certain privileges inside of vCenter, but they don't need access to everything. They don't need access on editing ESXi hosts, for example. Next, we can look at certificates for our vCenter. So you can find this in the administration tab under certificates in the navigation pane, which you can see in our screenshot there. So certificate management page provides the following options. We can view details of the existing certificates, and we can view details of and add trusted root certificates. Now, some of the actions for those individual certs. We can renew the certificate if we're utilizing the built-in certificate authority within vCenter. We can just renew those from the UI. We can also replace these self-signed certificates with external third-party certificates. Say if we have a wildcard cert that's used for internal servers, we can install that here. And depending on exactly how you manage your certificates in your environment, we can even generate a CSR, a certificate signing request for use with a third-party CA. Now, when we're importing and replacing certificates can get kind of complex in how you manage them as an organization, and vCenter should be able to support all of the normal use cases of installing and utilizing certificates. So we can replace with the VMCA certificate, so that's the VMware certificate appliance or certificate authority. So this is, again, built into vCenter by default. So vCenter will manage its certificate and all the certificates of the ESXi hosts underneath it. But if you prefer to utilize your own organization certificates, we can replace them with an external certificate in a couple of ways. One where vCenter generates a CSR, which will have a private key embedded in that CSR to make sure that only the vCenter server can access and utilize the certificate that is generated by your internal CA or third-party CA. Or we can just replace it with an external CA certificate, which require a private key that's sent in that certificate. Again, something like a wildcard cert would match there. So we have our certificates. We have trusted communication between clients to vCenter and to our ESXi hosts to vCenter. So now we just need to look at how do we want to back up and restore our vCenter server appliance securely, right? It's really easy to just take a snapshot or just take a backup and just have it sitting on a file share. But if that's not secured, a malicious actor could grab that backup, take it and put it into their lab and boot it up and then start to look for security vulnerabilities that they can use to attack your vCenter server. So we want to make sure that those backups are also secured no matter how we want to actually back up our vCenter server. So it does have a built-in backup service, which you can access via the management interface for vCenter server. So you'll notice in the screenshot, we have highlighted the URL. To get to that management interface, all you need to do is append 5480 as the port that you're trying to access on the FQDN, which is our vCenter server appliance. And that's basically telling vCenter, hey, I want to talk to you on your management interface. And that's how you're able to get to the specific web page and get back-end management access into vCenter server. Again, something you want to firewall for only your admins to have access into. So this removes dependency on third-party backup tools. You don't need Zerto. You don't need to do like a third-party backup tool. vCenter has it built in, and it has a number of supported features. So we can support FTPS, HTTP, HTTPS, SFTP, and so on. And it includes the option to encrypt backups, meaning you need a passphrase to actually access that backup. And it gives you the ability to restore directly from the vCenter server GUI appliance, GUI installer. Excuse me. And when you do that, you can restore vCenter service instance to a brand new appliance, right? So you can deploy a brand new vCenter server appliance and import all of your configurations into it if you think there's something corrupted with the OS of your original vCenter server appliance. We're running low on a bit of time, so I'm going to try to make sure we can get through all of the content. Again, securing vSphere is very detailed, and we are just brushing against some of these topics. So some additional different methods to backup and restore vCenter server appliance, some of which we've touched on. We have file-based backup and restore. This is an example of the vCenter server management interface. That's a file-based backup. You can restore the backup through the GUI installer of the appliance, and you can schedule these for reoccurring backups. Then we're looking at things like image-based backup and restore, which you'll generally see with third-party tools. This utilizes vSphere storage APIs and data protection, so the third-party backup product can actually perform serialized, efficient, off-host, and local area network free backups. Finally, for auditing purposes, vCenter server events gives us an audit trail, which will allow selectable retention periods in increments of 30 days. So you can go 30, 60, 90 if you want. And it includes user action information, which you can see will include the user account and any specific event details. So all actions are reported, including file ID, file path, and so on. And events and alarms are displayed to alert the user to changes in the vCenter service health or when a service fails. So you don't necessarily need to go in here to see if a service failed. You'll generally be alerted if something's going on with the server. So with turning on loggings, we can set log levels to control the quantity and type of information that is logged. So here are some of the examples that we have on the right, and these are generally your options with logs. None, so there's no logs. Error only, so it's only going to send logs of error activity. Warning, info, verbose, and trivia, which is an extended verbose. Generally, you only want verbose and extended verbose under the guidance of VMware support while they're looking for something. So real quick, real touch on VMware VM security. So VMware hardware security means, when a user is accessing a VM, they are utilizing a variety of different physical and virtual hardware, right? USB devices from the user's computer is, being translated into that virtual machine, and we have a number of resources we can apply to that virtual machine. So to secure it, in most respects, is equivalent of a physical server, right? We want to make sure we're keeping it the OS patched. We have other protections, such as a VM-specific firewall or malware detection with something like Carbon Black. We want to make sure we're protecting serial ports. We're removing unnecessary hardware devices, again, reducing the attack vectors that are available, and disable any features such as display, unexposed, disable copy and paste features, even if you want the ire of your users. So, uh, securing virtual machines are very important because this is where your production workloads are going to be located, right? And this is what most cyber attacks are going to attack is those virtual machines, right? That's where all the data is. So attacking ESXi, attacking vCenter is just a means to get to your virtual machines. So in addition to robust access control policies to systems, VM Beans uses encryption technology to secure applications, databases, and servers. So a trusted security consulting firm will assist VMbeans vSphere administrators in rolling out a secure key management server. So KMS for your vSphere infrastructure. It'll encrypt important virtual machines and ensure that virtual machines are secure during migration tasks, such as with vMotion. So looking at that encryption, this was introduced in vSphere 6.5. This encrypts the VMDKs or the disks of that virtual machine and can only be accessed with a digital key. vSphere access control will restrict access to the digital key itself for decryption. It'll it'll encrypt in-flight data. So even if you don't have the key, you can't just sniff packets in between, network communication on that VM. That traffic is also encrypted. So this is good, network communication between the encrypted virtual machine and other networked systems. So some advantages of this: does not require in-guest agents. It's all handled by vSphere. Its methodology is uniform across all OSs. Protects all VM data, including swap files, not just that VMDK, but any storage files for that VM. You have very detailed key control, so you can have VMs and even different disks utilizing different keys. So just because you get one key doesn't mean you have access to all the disks available on that VM or all VMs. And it's orchestrated through VM storage policies. Again, keeping that centralized repository and access through vCenter itself. And this is compatible with KMIP, an industry standard language. So encrypting vSphere vMotion secures the confidentiality, integrity, and authenticity of data that is transferred during a vMotion task. So this supports all variants of vSphere vMotion for unencrypted VMs. So even if the VM itself isn't encrypted, when it's moving across ESXi hosts, it is encrypted there. So we can make sure that during vMotion, whenever your vMotion network is sending packets over the wire to this other ESXi host, those packets are encrypted. And that is the end of our session today. So I know we only have a minute or two. If there are any questions that we have in the comments, definitely feel free to reach out and ask, and I'll be happy to oblige. Great. Thank you, Shannon. Okay, great. Well, everyone, thank you so much for joining us. That's all of my time here for today's session in 27 Virtual's webinar series. Stay tuned to our LinkedIn page to get the details for the next session. NSX for known threats. Again, tying into that distributed firewalling for securing access to and from your virtual machines. Uh, that session is actually scheduled for January 11th. Same time and place in our LinkedIn. So thank you all for joining me. I see we had a question of what type of services does 27 Virtual offer. So we offer a number of consulting and training services, right? If you want, if you have a new VMware product that you would like to get installed, such as NSX and distributed firewalling for securing your virtual machines, we'll happily come in, sit down and design an entire NSX environment for you that works to whatever features you're looking for, and even maybe some features you're not aware of, and how to best implement them into your environment, including like red tape, right? Securing applications can be very difficult. So we'll help guide you through that process, give knowledge transfer all along the way, create very detailed documentation, and, just hold your hand throughout the entire way and make sure that by the end of it, you know what to do with NSX. So you're not just ending up with a product that's installed and configured, but your team doesn't know what to do with. But if you do want extended service with NSX, we also offer training. Uh, 27 Virtual started as a training company, so we can actually take you and any number of your employees through training courses on a number of VMware products, not just NSX. So that's just a couple of services that 27 Virtual can provide. For full details, definitely reach out to us. You're more than welcome to reach out to me directly or to 27 Virtual on the LinkedIn page or an account executive if you have one already. So thank you all for joining me. That's all the time we have, and we'll see you next time, January 11th, for NSX for known threats. Thank you.